Hello and welcome. Today, we're diving deep into the fascinating world where cutting-edge entertainment meets powerful computing. The architecture behind cloud gaming and AI streaming. Get ready to explore the intricate systems that deliver immersive experiences directly to your screen, no matter your device. Cloud gaming, often hailed as the future of interactive entertainment, is experiencing explosive growth. Valued at approximately $2.27 billion in 2024, the global cloud gaming market is projected to skyrocket to $96.67 billion by 2034, demonstrating an astounding compound annual growth rate (CAGR) of 45.52% from 2025 to 2034. This exponential expansion is driven by the promise of playing graphically intensive games on any device without the need for expensive local hardware. Simultaneously, AI streaming is revolutionizing how we interact with intelligent systems, moving real-time inference to the cloud and edge. At its core, cloud gaming operates on a simple yet technologically complex principle. The game isn't running on your device. Instead, powerful servers and remote data centers do all the heavy lifting, rendering the game's visuals, processing physics, and managing game logic. What you receive on your smartphone, tablet, smart TV, or low-end PC is a high-quality video stream, while your inputs are transmitted back to the server in real time. This gaming as a service model democratizes access to AAA titles, eliminating hardware barriers and offering unprecedented accessibility. The backbone of cloud gaming is a robust infrastructure housed within highly specialized data centers. These facilities are packed with high-performance GPUs, graphics processing units, and CPUs, central processing units, often virtualized to create individual instances for each player. Major cloud providers are deploying thousands of cutting-edge GPUs, such as NVIDIA's H100S, H200S, and even GB200S, to handle the immense computational demands of modern games. This server-side horsepower ensures games are rendered at high resolutions and frame rates, supporting features like ray tracing that would otherwise require top-tier local hardware. The orchestration of these resources, often using technologies like Kubernetes, allows for dynamic scaling and efficient resource allocation. Latency and bandwidth are the twin pillars of a successful cloud gaming experience. Even a few milliseconds of delay can turn a fast-paced action game into a frustrating slideshow. To combat this, cloud gaming architectures heavily rely on low-latency networks and the strategic deployment of edge computing. Edge servers, located geographically closer to end users, minimize the physical distance data must travel, drastically reducing round-trip times. Furthermore, efficient video codecs like H.264, H.265, HEVC, and increasingly AV1 are crucial. AV1, in particular, offers superior compression rates without compromising visual fidelity, enabling sharper graphics and smoother frame rates over variable internet conditions while consuming less bandwidth. Netflix, for instance, has embraced AV1, with plans to use it for cloud gaming to deliver high-quality, low-latency experiences. Artificial intelligence is not just a player, it's a game-changer within cloud gaming. AI-driven upscaling technologies like NVIDIA's Deep Learning Supersampling, DLSS, and AMD's Fidelity FX Super Resolution, FSR, are revolutionizing graphics. These technologies allow games to render at lower internal resolutions and then use AI models to intelligently reconstruct a higher resolution image, often exceeding the visual quality of native rendering with significantly improved performance. DLSS, leveraging dedicated tensor cores on NVIDIA RTX GPUs, uses deep learning for superior image reconstruction and frame generation, with DLSS 4.5 even introducing dynamic multi-frame generation for up to 6x frames on RTX 50 series GPUs. AMD's FSR, while often hardware agnostic, is also evolving, with FSR 4 in 2025 expected to integrate machine learning for enhanced upscaling and frame interpolation, similar to DLSS. Beyond upscaling, AI is used for dynamic resolution scaling, intelligent non-playable characters, NPCs, procedural content generation, and analyzing player behavior, creating more immersive and adaptive gaming worlds. The architectural principles honed in cloud gaming extend far beyond entertainment, finding critical applications in real-time AI streaming. Industries are leveraging this to deploy AI models for instantaneous inference across vast and distributed environments. Consider autonomous vehicles, where AI models must process sensor data in milliseconds to make critical navigation decisions. Or industrial IoT, where real-time analytics detect anomalies in machinery, preventing costly breakdowns. Medical imaging, fraud detection, and personalized customer experiences are other areas where immediate AI insights are paramount. This requires event-driven architectures that can process continuous streams of data, trigger real-time inferences, and deliver automated responses with minimal delay. Cloud and edge computing improvements, along with serverless ML patterns, are key to delivering these low-latency, cost-efficient, and scalable AI solutions. Both cloud gaming and AI streaming face significant architectural challenges. Latency remains the perennial foe, directly impacting user experience and the responsiveness of AI models. Network congestion, jitter, and varying internet speeds can introduce noticeable delays. Scalability is another hurdle. How do you dynamically provide resources for millions of concurrent users or AI inference requests? Security of streamed data and intellectual property is also paramount. Solutions are multifaceted. The continuous rollout of 5G networks and the advent of Wi-Fi 8 promise ultra-low latency and higher bandwidth. Edge computing brings processing closer to the user, and hybrid cloud gaming models, which split workloads between local devices, edge servers, and the cloud, further optimize performance and latency. Decentralized GPU cloud infrastructures, like Ether, are also emerging, offering distributed computing resources globally to enhance resource optimization and reduce latency. Innovation in underlying technologies is constantly pushing the boundaries. The widespread adoption of 5G and the introduction of Wi-Fi 8, expected to pioneer at CES 2026 with MediaTek's Velogic 8000 series, are critical for ultra-reliable, low-latency connectivity, especially for AI-enabled environments and cloud gaming. Beyond networking, specialized hardware plays a vital role. AI accelerators and data processing units (DPUs) are designed to offload and speed up networking and security tasks, freeing up CPUs and GPUs for core processing. Advances in GPU virtualization continue to improve resource sharing and efficiency. Furthermore, software-defined networks, SDN, and serverless computing paradigms offer greater flexibility and automated resource management, allowing infrastructure to adapt rapidly to demand. Event-driven architectures, with components like Apache Kafka and Flink, are becoming fundamental for real-time data streaming and AI-ready pipelines. Looking ahead, the architecture behind cloud gaming and AI streaming is set for even more profound transformations. We anticipate hyper-personalized gaming experiences, where AI dynamically generates game content, adapts narratives, and creates NPCs that learn from player interactions. The metaverse and immersive AR/VR experiences will become mainstream, requiring even lower latency and higher fidelity streams, integrating cloud gaming and AI inference directly into our augmented realities. The industry is also keenly focused on sustainability. With data centers consuming a significant percentage of global electricity, there's a strong push towards green cloud computing, utilizing renewable energy sources, energy-efficient hardware, and optimized cooling systems to reduce environmental impact. These advancements will not only enhance performance but also ensure a responsible future for our increasingly cloud-powered digital world. In conclusion, the architecture behind cloud gaming and AI streaming is a complex, dynamic, and rapidly evolving landscape. From high-performance cloud data centers and low-latency edge computing to advanced video codecs and AI-driven upscaling, every component is meticulously designed to deliver seamless, real-time experiences. As technologies like 5G, Wi-Fi 8, and specialized AI hardware continue to mature, we can expect even more immersive, personalized, and environmentally conscious digital interactions. The future of gaming and AI is unequivocally in the cloud, powered by an intricate dance of hardware, software, and intelligent algorithms.